word is innovation. Now, for this conference session, the title is 3D Printing, a Catalyst to Innovation. And I agree with that 100%. But also, you can turn that equation around. Innovation is a catalyst for 3D printing. A, to create new technologies, new solutions, new processes that allow us to do more and move forward. But B, and this is off topic, it's a catalyst for you or the companies that use the technology to innovate how they are doing things. I'm a big believer if you're trying to substitute for something that's already working and you just want it better or just faster or just cheaper, it's a bad solution. You've really got to change things. You've got to look to do things differently, make it an alternative instead of a substitute. Examples of that, which you're probably familiar with, are like 3D printed cars and 3D printed shoes. The top car is from Local Motors. It's called the LM3D. You can place a pre-order spring of 2016. 75% of that is 3D printed, single pieces, not joined. What they're going after is a greener solution in manufacturing, a greener solution in emissions. Also, the flexibility and ability to roll out a new product much, much faster. Just below it is another car, 3D printed. It's called the Blade. It's a supercar. I happen to like this one better because they selectively picked the most advantageous place to apply 3D printing. There's only one 3D printed component on that car. Happens to be 10 or 15 different versions. It's an aluminum node into which carbon fiber tubes are inserted to create the chassis, an ultra lightweight chassis that eliminates all the traditional manufacturing to make a rigid chassis out of metal or other materials. 3D printed shoes. A couple of years ago, 3D printed shoes in all plastic and download them and we'll be 3D printing our own shoes and all of us will be wearing mass customized shoes was all the rage. Didn't believe it. What I believe now is a more realistic but yet innovative approach by New Balance and Adidas. They're 3D printing just the midsole. That's the performance area. That's the comfort area that depends on how your foot falls. It depends on your weight distribution, so they're going after the thing that makes the most sense to innovate. So I challenge each of you, or the people you interface with, or people you communicate with, to keep looking for innovative applications for the technology instead of trying to do the same old, same old. Now, innovation, keep that word up there, is coming. We are in an age, or entering an age of innovation in this industry. Contrary to past news reports and the trend a couple of years ago where there's their impression that we had innovation on a daily, weekly, or monthly basis. Every time you turned around, there was a new innovative product. That wasn't true. For the last decade, we've been mostly evolutionary. Moving the technologies forward incrementally to improve them, which is always a good thing. You can only innovate once, but you can continually improve. So it's not a bad thing, but they were mislabeling. The media and pundits were mislabeling these incremental changes as innovation. Today, I truly believe we are bringing innovation to the forefront, and evolution will still be there, but it's going to move to the background. And my logic is that it takes time to innovate. You don't come up with an idea and launch a product overnight. I think it takes roughly 5 to 10 years if you're lucky, because you've got to have the initial idea. Then you've got to do some fundamental research. Then you've got to do design and testing and redesign and testing. And then you've got to get some capital. Then you've got to go into alpha testing and beta testing and get more capital. Then you've got to build a business, build the infrastructure, build a support structure. All of that takes time. Well, the real hype around 3D printing started to build about 5-6 years ago. And if it's a 5 to 10 year time frame for innovations to come to market, we're right now on the leading edge. And I think we are going to see an age of innovation easily for the next 3 years. It could go for 5 years. It could go for 10 years, but easily for the next 3 years. And we've already heard from the harbingers, and that innovation will not just be in technology. We've heard materials innovation, but it's also going to be on the front end, the software. It's going to be on the process, the machines, the materials, post-processing. Everything about the 3D printing landscape is being looked at and has the potential to be innovative. So we're going to see significant movements forward in the technology. As we have heard from our harbingers, TCT and CES did an excellent job of the speaker lineup because it just so happens that the 3 companies I use as harbingers, the leading edge of this wave, or this age of innovation, happen to be HP, Carbon 3D, and Voxel. I like HP because they've got a balanced solution, delivering their promises to deliver speed, material characteristics or durability at a low cost with repeatable performance. That's something that's a bit elusive in our industry right now. Carbon 3D, as you just heard, initially hit the media all about speed, 100 times faster, and people went gaga over that, and that is impressive. But if it was just 100 times speed and everything else was marginal or unacceptable, it would never take off. I got excited when I heard about the material properties, when that information started to come out, because now we got this balanced solution. Speed with exceptional material properties that weren't previously available. And material properties also applies to Voxelate, as we heard in the presentation earlier this morning. If you happen to miss it, there's a developer kit available that allows you to print two materials simultaneously so you can 3D print electromechanical assemblies. So these are our harbingers, but they're not going to be the last ones in this age of innovation. I'm going to speak to trends. I can't talk about all the new technologies, all the evolutionary or innovative advancements in our industry, because there are way too many of them. So I'm going to try to present trends to you. One trend I'll just pull off of the floor here at CES. These are pre-announcements of what was going to be released on the show floor. However, this trend is that nothing that I'm aware of is innovative. Everything is in the evolutionary class. Again, that's not a bad thing. It's necessary, but we're seeing evolution. First up, 3D systems with the DMP 320. This is a metal 3D printer. Reasonable size, about 11.5 by 16 inches for a build envelope. What they're doing is they're coming back to the market with second generation technology because the first generation technology really wasn't up to speed. Users weren't satisfied with it overall. So they've come out with a new machine to address those issues of early innovation from the company. This uses a process called laser melting. A laser is directed onto a bed of metal powder, which causes it to melt and rapidly solidify. But they're also building this machine to be more industrial, which is a sub-trend that we're seeing in this industry. Rock solid, dependable, repeatable, and taking out a lot of the lost time, the non-value added time of waiting to change out parts and feed material. They're also introduced the MJP 3600. MJP stands for multi-jet printing. This is ink jetting of photocurable resins that are cured or solidified immediately after being deposited. The MJP 3600, incremental advancement, 2 times the speed of its predecessors in the same class from this company. They also introduced, this is in beta, so there's no photos and no details, the MJP 2500, purely an entry-level solution. That's it. That's its evolutionary advancement. It was necessary because they were missing an entry-level solution. Oh, by the way, entry-level does not mean $4,000. We're talking tens of thousands of dollars. I've got MakerBot up here. It doesn't deserve to be in the what's new, but it reinforces the concept that first iteration of innovative product isn't always rock solid and sound. You have to put up with some issues. They've introduced the Smart Extruder Plus, as Joe Kempler of Canalys mentioned earlier today, to overcome the issues of the Smart Extruder that they introduced 2 years ago here at CES. Problems with oozing and the life of the nozzle, the head, for the deposition process. So they're fixing problems. Again, not a bad thing, but it's not innovative. XYZ Printing. 8 new machines down on the show floor. 4 of them in the FDM class where they're extruding thermoplastic materials. They got a mini, they got 2 juniors, and they got a pro. One of them is one material, one of them offers you the ability to mix materials out of a single nozzle, and 2 of them offer 3-in-1 capability, 3D scanning, 3D printing, and laser engraving. They've also got 2 new products in their Noble line. These use photopolymers. The Noble DLP, which is a digital light projection technology, so a DLP chip, like in the projector used for this screen, casting a pattern of light onto a photocurable material to create solid 3D printed parts. Now, is that going to be something you should take a look at? I don't know. Details aren't available to the extent to convince me that it's better than the competition. So it might be a Me Too product. They also have the Noble, a new Noble solution for SLA, stereolithography, which uses a laser and photocurable materials. Now, new for XYZ Printing are 3 new classes of technology that have existed for several decades. They've got a jetting solution called 3D Jet. It's much like the multi-jet printing from 3D Systems. They've got a jetting solution, and I forgot the other one, but then they've got a system they're calling 3PP0A. I have no idea what that means, didn't ask, but this is a binder jetting technology, been around for about 20 years, jetting a binding agent onto a bed of powder. Multicolor, So full color parts, and their claim to fame on this one is going to be 3 times faster than the nearest competitor. But again, incremental advances. Former's Farm, Asian company, going global. Actually, Asian company with products in the FDM class, the extrusion of thermoplastics, called Sprout. Those are existing. They announced 2 systems. One's called PickCarve, which is kind of 3D printing. It's to make lithophanes, which I didn't even know what a lithophane was. These are basically images that are 3-dimensional. Imagine an etching or a wood relief. When you backlight them, the details pop. So you can 3D print those. Also announced a system called Orsis, which is mixing of 2 materials in the extrusion head to be deposited. That allows you to create new colors, maybe blend for material properties, and also have the concept of support structure I shouldn't get into, but support material and model material out of the same head. They're claiming that they do it better than everyone else. Who knows? They're claiming no ooze and no cross-contamination of materials. Time will tell. PrintRight has down on the floor a product called Kalido DLP, again like XYZ Printing. I don't know if it's something worth looking at. It's something you should definitely take a look at and ask questions about, but is it differentiated? Is it better than everyone else? Who knows? It could be a Me Too product, which we have a lot of those in this industry, with all the interest in the industry. But they also announced, or they're going to show a part from the Kalido Mega, which is fused deposition modeling. That machine is capable of producing parts up to 40 inches by 60 inches, which is a trend that I'll discuss a little bit later, trend to go bigger, away from the consumer products and the desktop machines and get into the bigger, more industrial systems. So they're going to have this system, I think they're going to show a part that stands about 5 feet tall. Also on CES floor, Beijing Tier Time, the Up Mini 2, version 2, purely evolutionary. They've taken the user input and said, okay, you want these features added for portability, usability, and connectivity? They add them to the new version. But it is a new system, just not innovative. Titan Robotics came out with the Atlas 2.0. This is the follow-on to the Atlas 1. It gives you a little bit bigger build envelope. It is a big machine. It's roughly 3 foot by 3 foot, not the machine, the build area, 3 foot by 3 foot by 4 foot. But what they've done, if you look at Atlas 1, it was one of those, I shouldn't say this, but cobbled together, kind of engineered built just to get a concept out. This one they're claiming is bomb-proof. Bomb-proof meaning that heated build chamber, control over the process, and a design and manufacturing and quality of components that mean that you got repeatability and reliability out of the machine. 3D Printer is the only software company I'm going to mention today, just because they're on the floor. They label themselves, this is an easy one to describe, as the kayak of 3D printing. So it's a price shopping tool. Upload your file, get prices from various marketplaces, and pick based on price, which, word of warning, same technology, same material, same controls available to everyone, you'll get different outputs from these technologies. So I would never, ever buy solely on price. And finally, Envision Tech. So DLP's been mentioned a couple of times. This is the company that came to the market with DLP in the first place, about 12 years ago. They've got 2 systems. The one on the lower left is a small desktop unit, building parts in the 2-inch range by 8-inch tall, called the Mini. The Mini is purely evolutionary. It's a new look, plus some touchscreen added, some connectivity, some issues. User desired, makes the experience better. And the Vector 3SP. 3SP was an innovative technology 2.5 years ago. It's a different take on stereolithography to increase speed, lower operating costs. But the Vector is filling a hole in their product line. So they had large machines, they had small machines. The Vector sits right in the middle of those. It's needed, it's necessary. It helps, it gives us solutions, alternatives, but it's not necessarily innovative. Now with all that, I've thrown a lot at you. That's just on the show floor here. We've had 2 other major events in the last 3 months with lots of announcements I can't cover. So I'm probably overwhelming you a bit, kind of my goal. I want to give you a flavor of the industry instead of teaching you about each and every one of these and cause you to go investigate. But with that, with this overwhelming nature, we have a good problem to have. This is a dynamic industry that's fast moving. Lots of new announcements, not lots of new products. I believe a future trend is segmentation. Segmentation of this industry is going to be absolutely necessary. I believe it's ludicrous to talk about things the size of measured in microns, out to things measured in feet or yards. I think it's ludicrous to talk about bio applications right next to building applications. We need to segment this market by class of technology, by the industry it serves, or by the application, or by any other method. But we haven't reached the size yet to slice and dice this industry and to make it look as, to have the impact, the size, the substance, that's the word I'm looking for, to segment. But we need to do that, because it makes no sense to talk about all these in one breath. Now, continue with trends. As Joe Kempler already mentioned with Canalist in a presentation before lunch, the 2D players are coming to this industry. We know about HP. Canon announced late last year that they're coming to the industry. No details. They're calling it resin-based lamination printing. They're not telling us how it works. They're only telling us that they're going to go after speed issues, material property issues, material selection, meaning diversity of materials, and also post-processing, minimizing the effort after the 3D print job's done. We don't know when it's going to be released. We don't know how the technology works. They're teasing us right now. But it will be their own technology. Rico, on the other hand, went a different direction. It came into the market, not in the North American market, it's Europe and Japan right now, by partnering with a long-established manufacturer of laser sintering technology. So this is using a laser on a bed of powdered plastic, where the heat from the laser causes the plastic to reach near melting point, so it tacks together. They partnered with another Japanese company called Aspect, which has been making selective laser sintering machines for many, many years, but just didn't have the resources, the size, the mass, the financial wealth to go global. So they partnered to bring that to other markets outside of Japan. Fuji's coming. Don't know when. They made a very public announcement that they have patents in the 3D printing space, and they plan to be in the industry in about 5 years. And I guess it's 4 years now, because it was about a year ago they announced. And Epson most recently came out and said, yes, we're going to be in the 3D printing industry also in 4 to 5 years. They want to attack speed and properties and quality. Don't know how, no indication of what they're going to do, but they're all coming. This will be a good thing for the market. I really like, as Scott Schiller in HP's presentation mentioned, I really like what they bring in the quality of the build, the attention to detail, that every product is the same, and also the support on the back end. Supporting high-volume printing requires a lot of logistics and resources, things that we're missing right now. Now, will these guys walk in and march all over the existing players? No, I don't believe so. At least it's not a given. They could, but as you'll see throughout this presentation, a single technology cannot handle the needs of a large swath of applications. We've got a lot of technologies for a reason. Each one has a niche. And also their size may actually be a hindrance because it is so dynamic. If they're slow moving like a large corporation, that could be a problem. But it will be good for the industry, and as Joe said, it gives us validation. Trend number 2, moving to bigger. We already talked about a couple on the show floor, but we're going big. Oak Ridge National Labs, in cooperation with Cincinnati Incorporated, they're bringing BAM, big area additive manufacturing, to the marketplace. And when I say big, it's big. That's what was used to 3D print, or is going to be used to 3D print the Local Motors car. It's got a build envelope of 20 feet by 8 feet by 6 feet. It's a monster. It deposits, it's an extrusion process, it's FDM, it deposits 100 pounds of plastic an hour. Now, what Cincinnati did, first off, Cincinnati is a traditional machine tool manufacturer. So not only do we have the 2D players coming in, the HPs, Canons, and Fujis of the world, we also have the traditional machine tool market. What they did is retrofitted an existing water jet cutting machine tool and added the additive manufacturing head. They already had all the mechanisms, so rapid launch. Also going to be an open platform, use whatever material you want to reduce material cost. Norsk Titanium, NTI, focused purely on metals, and specifically titanium for the aerospace industry. It's also a big machine. Now, relative to BAM in Cincinnati, not so big, but relative to the metals marketplace, it's quite large, huge actually, 4 foot by 4 foot by 7 foot. It's using plasma arc welding. So here another sub-trend is we are pulling from traditional manufacturing processes, adding the third dimension to make them 3D printing technologies. Plasma arc welding has been around for quite some time. Cosine, Supports the trend that's shown on the floor. This is FDM, so Extrusion of Plastics. They are have launched with an FDM platform that is meant purely for industrial applications and large parts, building about 3.5 feet by 3 feet by 3 feet. Give you an idea of price, though. It's $72,000. It's a far cry from $2,000 or $600 for a desktop machine. But it's heated building closure, and they're looking to make it a reliable, dependable solution. And there's others too, 3D Platform and others out there with larger format machines. Massivit, if that's how you pronounce it. Read it many times, never actually conversed about these guys. This is innovative technology, borrowing from a couple of different aspects of 3D printing. They call it gel dispensed printing. They're extruding a material, but that material is a photocurable resin in a gel form, so it's extrudable and it holds its shape, and then they're hitting it with UV light to cure the parts. Large format machine, as you can see the silhouette of the man, and they're stating that they can make a full-size statue of a human being in 5 hours. Really, really fast. Now, that's a full-size human being, not my size human being. So actually 6 foot, 6'2". X1, to wrap up the bigger, announced earlier or mid last year, came to market with it, the X-Serial. This is a system that you probably won't stumble on because it's dedicated to sand casting. Work for foundries. It prints the sand casting molds. Massive machine, and once again, you see a gentleman in that picture. 2 chambers measuring 6 foot by 2 foot by 2 foot, multiple print heads, all to increase the throughput. And the reason they got 2 chambers is so that when one chamber's printing parts, the other one can be having material added or parts removed. It's all about continuous production, getting rid of that lost non-value added time. That's another sub-trend. Metals is a big trend. Now, to clarify, though, the impression is that metals are taking over the world. There's roughly 2,000 or 2,500 metal systems installed globally, so it's a teeny, 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 tiny market, but highly attractive. First 2 companies on this list are long-established players in the metal marketplace for 3D printing. Renishaw, this machine that you see there, the Ren AM 500M, is built from the ground up, completely redesigned, new optics, new controls. It's all about industrial applications, much like 3D systems. This is a dedicated machine. You run one material in it, and you keep running that same material on and on and on and on, because it's all about rapid replacement. Build, get it out, build, get it out. EOS, probably the leader. Oh, and both these guys, EOS and Renishaw, use laser melting. So you're using a high-powered laser pointed at a bed of powdered metal, causing that metal to melt and then rapidly solidify, so it rapidly solidifies to create a solid part. EOS came out with the M100. This is an entry-level solution for metals, pure and simple. 100 stands for 100 millimeter diameter, so roughly 4 inches build volume. So it's small, but we need entry level because the price point for these metals machines starts around $500,000 to $600,000 and quickly gets into the millions. Plus Manufacturing thinks they have a different way of doing metals. Like the plasma deposition that I discussed already, Plus Manufacturing is pulling from the welding applications, but they're using an arc welder. They're using an arc welder in their machine called the Plus 1000, 1000 for 1,000 millimeters or about 40 inches, so it's large parts. Looking for high deposition rates, about 2.5 kilograms of metal an hour. Low cost because you're using the feedstock from the arc welding industry, so about $12.50 a pound versus 100, 150 or more a pound. And the ability to blend multiple materials, make multiple parts with different materials or blend materials in a single part. Now that's definitely a solution looking for a problem. Innovation has a challenge. If you're not ready to use the innovation, you've got to start changing mindsets and behaviors and get rid of the momentum. Muto is a traditional machine tool manufacturer that is also doing arc welding. A little bit smaller than the Plus Manufacturing system, but about twice the speed. Erler, German company, machine tool manufacturer once again. Their innovation is they are pulling from the thermal spray industry, long-standing manufacturing technology usually used for coatings. It's about softening or melting fine atomized metal powder and just blasting it at high speed at a surface where you get a mechanical bond that just basically splats of droplets that solidify and bond. That machine uses thermal spray, And it also includes CNC milling in the same machine, a concept called hybrid, combining additive and subtractive. Why? Well, all the arc welding all the welding processes produce a near net shaped part. Nowhere near ready for use. It's got to be fine-tuned significantly. So you have to machine all those surfaces to get the dimensional accuracy of the surface that you want. They've incorporated that in one platform. That is a trend moving forward. It's a trend that's in debate, though. Some people are saying, well, why not have two technologies sitting side by side, both of them working 100% of the time, instead of having both in one cabinet where one's always idle. So we'll see how that plays out. Toshiba, as was mentioned earlier, is coming to the market. Laser metal deposition. This is a long-standing technology where a laser generates a melt pool, a hot spot, and then blows powder into it to additively grow parts. We don't know much about the technology. We got a picture of it. They haven't disclosed much other than they want to be 10 times faster than the status quo, and that they're expecting to have the machine available in 2017. Yet another machine tool manufacturer, ELB Schliff. This product is called mill grind. The reason it's called mill grind is they're using their milling or their grinding platform, the traditional machine tool, and adding the additive manufacturing component. They didn't come up with their own technology. They're licensing the technology from a Texas company called Hybrid Technologies. And it is also a laser cladding process like I've just described with Toshiba. I think that's a sub-trend too, licensing of technology to other companies instead of trying to have it all your way. Trumpf, another machine tool manufacturer. Trumpf actually owns a lot of the IP that is under the hood of the existing solutions in metal 3D printing. Sorry, I'm using the two terms interchangeably. Trumpf was in the industry, got out, and they've now come back in. The reason I've got them up here is they got the true print and the true laser. True print is laser melting. True print is laser melting. True laser is laser cladding. Why do they have both? Well, back to one technology does not do the job for all applications. Laser melting is typically used for building parts from the ground up. The laser cladding process is usually to add features to an existing metal component. Xjet, this one is quite interesting, out of Israel. They will be jetting fine metal powders carried in a solution, ink jetting those powders. When the solution and powder mix hits a heated platform, the solution evaporates, and you get adhesion between the metal powder to print parts. They're going after speed while maintaining high precision and exceptional surface finish. They're going for detail, surface finish right out of the machine. Now, there is a secondary process here. Once it comes out of the printer, it's got to go into a furnace for sintering. Now, no picture available. I can't offer you any more details. These guys actually made a mistake at speaking at an investors conference, and news went out and it went public. They were trying to keep this thing stealth mode until they launched. So can't tell you any more, and they're not showing pictures of the machine. Aurora Labs. This one has me excited but also doubting. Aurora Labs is looking to produce a lower cost metal solution. They've got a system called the Titanium. Depends on, there's two versions. One sells for about $32,000. That's a far cry from $600,000. The other one for $43,000. Now, I'm not convinced you can drive the price down that far on the metal technology because it is involved, to say the least. Also, it's not something the casual user will want to use because fine metal powder can be an explosion hazard and also a health hazard. What really causes me to wonder where these guys are is they had a Kickstarter program or campaign. They were saying they were going to come out with a desktop metal printer for $4,000. Now, that Kickstarter campaign has been pulled. There's no other details. So worth looking at, worth considering. Whether or not it's something to buy into, I don't know. I don't have enough information. Multi-technology, we've already heard about the hybrid platforms. There's also a company called Fused Machine. Desktop extrusion FDM process along with a CNC cutter. Auto tool changing, so deposit some, machine some, deposit some, machine some. On the desktop in a reasonable build size, about 10 inches by 10 inches by 10 inches. Can't remember the price though. Rise is in hybrid, but it's combining, meaning additive and subtractive, it's combining two different additive technologies under one hood. So they're going to extrude thermoplastic and then follow up with ink jetting of an agent onto the part the layers that have been printed or deposited, that agent can change color of the part. It can change the material properties and characteristics of the part by being a plasticizing agent. So they're looking at giving you the option to fine-tune, as Joe was talking about, tunable materials on the machine using a technology that's fundamentally FDM. This should be coming out this year. No pictures, no other details on the technology. And I have Apple up here just for giggles. Apple, just because multi-technology, Apple, it became very public that they had some patents in the 3D printing space, and that patent says that it's going to be an extrusion, the one I'm thinking of, an extrusion process combined with a jetting process solely for the purpose of generating full-color 3D printed parts. No indication if they have any intent to come to the market, and certainly no indication of when. Speed is always necessary. We need more, we need more, we need more, but we need balance. I've already talked a lot about speed. I want to throw these two up here. Didn't know where else to put them. I'm actually going to put both up here. Nexa 3D and NuPro 3D. The picture is the NX1 from Nexa 3D. Fundamentally, the technologies are the same. They are using photocurable materials. They're creating an inhibition zone where the material won't cure to go after high speed. You'll have to go down to the show floor. NuPro is here, and they have a machine. They've published no details on it, and I haven't been to the show floor yet, so I can't tell you about that one. But Nexa 3D is claiming that 3 minutes per inch, per vertical inch of part, which is rather fast. However, the other caveat is it's going to be for parts with not a lot of material, not a lot of mass. So an Eiffel Tower with just the struts will print that fast, but you build a solid softball, it's not going to build that fast. But anyway, we're going after speed. And materials. Robos. This is a desktop FDM technology, so reasonably priced. Thousands of dollars, though, because they're going after materials that aren't readily available in this industry. Namely, PEEK and PEC, which are highly engineered thermoplastics that have really great temperature properties, great chemical resistant properties, used a lot in medical and aerospace applications. Right now, the only other solution you have for PEEK or PEC is to spend $830,000 for a laser sintering machine that there's maybe a half a dozen in the world. So they're bringing something new to the market. Impossible Objects is also doing something new. Voxel talked about composite parts. That's what they're approaching. So think Kevlar, think carbon fiber, think fiberglass. No picture of a machine because the machine doesn't exist. It's still a manual process right now with no date of release. What they're doing is jetting a solution onto the cloth of the Kevlar cloth or the carbon fiber cloth, putting a polymer powder over top of that, and then putting another layer of material on there. The solution only is to have the polymer stick where you want part. They stack them up, stack them up, stack them up, then put it in an oven and put it under compression to come up with a carbon fiber part. We've got carbon fiber filled materials in this industry. We have no carbon fiber parts or composite parts. That's a new alternative. Purely a research project. Who knows if this will ever come to the market? But out of MIT, the mediated matters is extruding glass. They're claiming optically clear glass. You can tell that they're kind of stretching for what the application will be because they're kicking around some ideas. Maybe we can print clear panels for buildings with embedded fiber optics. Who knows if the demand is there, but it's certainly interesting. They're not the only ones, though. There's also a company called Micron 3D that's 3D printing glass. Nano Dimensions, 3D printed circuit boards, purely for prototyping. Desktop units going to be available this year. It's called the Dragonfly. Multi-layer 3D printed circuit boards. They're printing the traces, not printing the components, the traces, and it's purely for prototyping, a faster way to get to your PCB prototypes. And finally, purely materials, HRL Labs with a ceramic material. Now, we have ceramics in the 3D printing marketplace, but they're claiming they can do it better. This is a scientific paper that has been written. I don't know where they're going to take it, but they've demonstrated that they can put their material in a stereolithography machine and come up with a nearly 100% dense ceramic part that's got superior properties. What intrigues me is it's called pre-ceramic monomer. So it is a liquid that's going in the stereolithography machine, and pre-ceramic has me intrigued. What do they really mean by that? It almost sounds as if they're creating the ceramic through the photo initiation in the stereolithography process. But here, that picture shows high heat resistance. Up to 2,500 degrees Fahrenheit is the ability, the temperature that it can withstand. Finally, about ready to wrap up, Automation. It is a trend, and it's going to be a growing trend, because if we want to be in manufacturing, we've got to drive out that non-value-added time. Two companies that have announced solutions are Concept Laser and Additive Industries. Concept Laser is an established player in the 3D printing space for metal additive manufacturing. Additive Industries is a new player. Concept Laser, their concept, Concept Laser's concept, is to break apart all the elements of the 3D printing process, make them individual modules, and then have robotic transport throughout all those modules. So everything keeps working 100% of the time. So as you're dealing with your powders and filling a chamber, that's over here while you're building. And then while you're building, there's a chamber with parts over here being removed, and then somewhere else you're recirculating the powder. All of that choreographed through robotic movement. Additive Industries sees the future a little bit differently. It's automation, but they want to take the modules and stack them one after one after one. So up to 4 chambers on this, up to 4 lasers, up to 4 materials can be produced. But behind that, it's automated handling of the build plate. It's automated depowdering. It's even got the furnace built into this modular approach. So ladies and gentlemen, those are the trends. And I know it's fast-paced. I know I didn't teach you anything about any of these given technologies. But with that, I tried to do my best to craft the themes. But I've only scratched the tippy top of this iceberg. There's a lot more to discuss that's out there, that has been announced, that's available to look at in the 3D printing industry. And below that surface, I'll tell you what, the innovation is coming. It's in the research labs, in companies, and universities. It's going to be a fun ride. Now, where that ride's going to take us, I do not know. What's around the corner? What's on the horizon? What does the crystal ball say? I don't play that game. I don't like to, personally, I don't like to look beyond 3 years, because who knows what the future holds. Young, dynamic industry, we're trying to find ourselves. We're crafting our future right now as we speak. But I will tell you that this industry is here to stay. We'll continue to see innovation, and it's going to be quite exciting times. Now, the other question I get asked often is, okay, with all these technologies, who are the winners and who are the losers? That's also something I'm not willing to predict. Because it's not a technology solution alone. It's a business execution issue. It's sales. It's marketing. It's support of your clients. It's delivering a reliable solution. And the other factor was carrying all those technologies like XYZ Printing, Trumpf, who I mentioned. One technology will not do the job, at least what we know of the technologies available. So we are going to have segmented solutions dealing with specific applications for specific materials for specific industries. But we will find ourselves. We're young, we're growing, we're dynamic. It's exciting as heck to be in this industry. A bit confusing, a bit overwhelming to stay on top of it all, but it's a fun ride. And I'll tell you what, I can't wait to see where we are 10 years from now. Enjoy that ride. Thank you.